In this video, we'll talk about how to find the determinant of a 4x4 matrix. So let's consider the following 4x4 matrix. How can we find the determinant of this matrix? Well, we can start by identifying which row has the most zeros. That would be the first row. So what we're going to do is use the values in the first row as coefficients for multiplying when we form the 3x3 matrices that we're about to form. So let's consider the first value of 0 in the first row. This is in row 1 in column 1. So what we do is we eliminate row 1 in column 1, and then we create a 3x3 matrix with the remaining values. So we need to write this 3x3 matrix. So let's do that. So we say 0 times that 3x3 matrix that we just saw. Okay, next we need to create another 3x3 matrix. And it's worth noting that the coefficients that we're multiplying by, they will have alternating signs. So the first value will be positive, the second coefficient will be negative, the third will be positive, and the fourth will be negative. So we're going to repeat the process using this next value of 0. So notice that we want to eliminate the row that the 0 is in and eliminate the column that it's in. And then we'll write a 3x3 matrix using the remaining values that have not been eliminated. So that would be the 2, 2, 3, 1, 2, 1, and 3, 3, 7. So let's write that. So we get minus 0 times 2, 2, 3, 1, 2, 1, 3, 3, 7. Okay, let's check out the next value in the first row. So that's a 4 right here. So we'll eliminate the row that the 4 is in and eliminate the column, and we'll write the remaining values as the matrix. So we get, remember this one is a plus, so plus 4, and we said it was 2, 2, 3, 1, 1, 0, and 3, 3, 7. And the last matrix, we said this will be the 6, so we'll use the 6. We'll eliminate the row it's in, eliminate the column it's in, and we'll write this 3x3 matrix as our matrix. And remember, we're using a negative this time, so we're having a negative 6. So we'll say minus 6 times, we had 2, 2, 3, 1, 1, 0, and 1, 2, 1. Okay, so what we need to do is multiply each coefficient by the determinant of each corresponding 3x3 matrix. But you'll see here that this will end up being 0 times whatever the determinant is. So this whole thing becomes 0. And notice the second matrix also has the exact same scenario. We're multiplying 0 by the determinant of this 3x3 matrix. So we'll get 0. So that makes our lives a little easier. So that's why we actually chose the row with the most zeros to work with, because it simplifies the amount of work that we have to do. So now over here we'll have 4 times whatever the determinant of this matrix is, minus 6 times the determinant of this matrix. Okay, so let's first find the determinant of this matrix. So if we have 2, 2, 3, 1, 1, 0, 3, 3, 7. To find the determinant of a 3x3 matrix, we can use a cool trick where we rewrite these first two columns on the outside of the matrix. So let's do that. So we get 2, 2, 3, 1, 1, 0. And now what we can do is we can identify the diagonals. So these 3 diagonals. And we will multiply the values on the diagonals and take the sum, and then we'll subtract the anti-diagonals. So 1, 2, and 3. Okay, so along the diagonals we get 2 times 1 times 7, that's 14. So we'll write 14 plus 1 times 3 times 3, that's 9, plus 3 times 2 times 0, that's 0. And then we'll subtract the anti-diagonals. So we get 1 times 2 times 7, that's 14, plus 2 times 3 times 0, that's 0, plus 3 times 1 times 3, that's 9. So the determinant of this matrix turns out to be, we have 14 plus 9 is 23, minus, we have 14 plus 9 again, so that's 23. So 23 minus 23 is 0. So for this entire portion right here, it becomes 4 times 0, which is just 0. So we have to add that with this negative 6 times the determinant of this matrix. So let's make a little room here. Okay, so we need to find the determinant of this 3 by 3 matrix. So we can use the same trick where we take these first two columns and we write them on the outside of the matrix. So let's do that. So let's write 2, 2, 3, 1, 1, 0. And once again, we're going to identify the diagonals. So there's 3 diagonals. And then we'll identify the anti-diagonals. Okay, and we will multiply the values along the diagonals and add them together. So we get 2 times 1, that's 2, plus 1 times 2 times 3, that's 6, plus 1 times 2 times 0, that's 0. And then we have minus 1 times 2 times 1, that's 2, plus 2 times 2 times 0 is 0, plus 1 times 1 times 3 is 3. So we get 2 plus 6 is 8, plus 0 is still 8, minus 2 plus 0 plus 3, that's 5. So we have 8 minus 5 is equal to 3. So the determinant of this matrix right here, is 3. And remember what we have to do. We have to multiply it by negative 6. So what we end up with is negative 6 times 3, which is negative 18. So remember, our final answer is 0 plus 0 plus, we found this was also 0, plus negative 18. So the determinant of this original 4 by 4 matrix is negative 18. That's our final answer.